Again, good morning, everyone. Please turn on your camera
Morning,
again.
sir.
EM, Sebes. All right. So where are we the last time with the discussion? Rabi, where are we the last time?
The classification.
Was it in the draft fault?
Yes.
All right. So as a review, again, draft fault is a fault in which two normal faults occur whose fault planes are inclined, providing a common down throw side between them. The block between the two faults plains forms a long trench called the graven or a reef valley. Some gravens are very long and also deep that may be filled with water and become water stream. So again, the last time I told you, I will let you know. We will discuss about the graven or graben and the what is the other one? Graven and
And
yes,
wait,
Rabi.
the Graben and the Rift Valley. Wait, what?
Graven and Rabi.
Graben or a Rift Valley.
Let's go back to Graven later. So let's move forward first to oblique sleep fault. Oblique sleep fault has a component of deep sleep, okay, and strike slip fault. So I mean to say this is a combination of two. So the movement there is parallel and horizontal. At the same time, there is a dripping and what? Submerging of some plates or some rocks. Generally, all faults have components of both deep slip and strike slip fault. It caused by a combination of sharing and tension of compressional forces. By the way, why do you think so that nature allows itself to be broken? Any idea? Rabi? EM? How about EM? Why do you think so? Why do you think so? Okay. Nature allows itself to be broken in order to form another um, natural resource or another formation. Like, for example, when you're going to look at a mountain, it actually destroys itself to form a mountain, right? And if you're going to look at some plateaus, it actually destroys itself in order to form a plateau, correct? Like generally, these sharing forces is naturally occurring in order to create another landforms. Going back to Graben and Rift, again, Graben and Horst. Now, if this is our illustration, The graben there is in the lower part. If you're going to look at this is the graben area. So I will annotate. Wait. This is the graben area. I will use. This is the graben area on the top. Yes, Rabbi. Rabbi?
Is the Graben area basically the footwall?
The graben area, basically the floor, the lower part.
It's basically the footwall of the trough fault.
Well, definitely, it depends upon the situation. Sometimes this graben will be the footwall. Sometimes this graben will be the other way around. It depends upon, because these forces may occur anytime, in any place.
Oh,
Yes, Rabbi? Any other question?
but it's the one in the middle.
Yes, Rabbi, again?
It's always the one in the middle.
It's always in the one in the middle, correct. Or in the lower part. Okay? You
Okay, sir.
need to
Okay, sir.
analyze
Thank
the
you.
image. Sometimes I will give images in order for you to analyze. You need to analyze the image and identify some areas. Like for example, in this image, the trough fault, the graben there is in the lower part. This one. This is the graben. And the horse is in the upper. Wait. Can you see my share screen?
Yes, sir.
Yes.
The upper part is the horse. Now, if you're going to look at it, it actually creates a landform, right? It creates a landform. This is because of the forces acting on it. Okay? Hopefully, as we will go along with these formations, we will have an activity with this. Okay, let's move now to oblique. You're done with oblique. Okay. Let's move now to earthquakes. Okay, earthquake. What is an earthquake? By the way, earthquake is what happens when two blocks of earth suddenly slips past one another. The surface where they slip is called fault or fault plane. This is the area where, fault happened. The location below the earth's surface where the earthquake starts is called the hypocenter or hypocenter or focus. Right? Again, the earth's surface where earthquake starts is the hypocenter, hypocenter, or focus. Hypo means below. And the location directly above on the surface where you can feel the earthquake is called the epicenter. Okay, you're familiar with the words, right? Are you familiar with the words?
Yes.
Great. Now, hypocenter or focus and epicenter is commonly used for public signal warning and commonly used in identifying earthquakes in a particular area. Like for example, have you noticed the previous earthquake, like in Bohol? Have you heard the news? EM, please turn on your camera. Have you heard the news previously? in Bohol.
When, sir?
That's 6.5 magnitude, I think, or 7.5 in Bohol. So there is an earthquake happened in Bohol, and the epicenter is the Bohol, particular side of Bohol. So epicenter and hypocenter are used in identifying the sources of earthquake or where the earthquake came from. Now, what are the causes of earthquake? So we identified last time some of the causes of earthquake. The earth has four major layers. Please read, Rabbi. Rabbi.
The Earth has four major layers: the inner core, outer core, mantle, and crust. The crust and the top of the mantle make up a thin skin on the surface of our planet.
Correct.
But this skin is not all in one piece. It is made up of many pieces, like a puzzle covering the surface of the Earth. Not only that, but these puzzle pieces keep slowly moving around, sliding past one another and bumping into each other. We call these puzzle pieces tectonic plates, and the edges of the plates are called the plate boundaries. The plate boundaries are made up of many faults, and most of the earthquakes around the world occur on these faults. Since the edges of the plates are rough, they get stuck while the rest of the plate keeps moving. Finally, when the plate has moved far enough, the edges stick on one of the faults, and there is an earthquake.
Correct. Okay. It is one of the major causes of earthquake, the plate tectonic theory. We'll not discuss the plate tectonic theory here because plate tectonic theory will be discussed in your earth science. Aside from that, plate tectonic theory is a long topic, right? But it's good that we know plate tectonic theory and the plate boundaries. Again, Earth is composed of inner core, outer core, mantle, and crusts. Crust is the topmost where soil is actually observed, where plants, animals stay, or the biosphere stay. Are you familiar with the biosphere? Anyone? Biosphere.
The value sphere?
Yes.
Oh, biosphere, yes.
Biosphere. Any idea with the biosphere?
Is it is it the part of the earth where excuse me where life stays?
Correct. Correct, Rabbi. It is the part of the earth where life exists. That's the biosphere. So the biosphere actually located in the crusts. Okay. When you say mantle, this is where your molten rocks is being located. Okay. The liquids, there's your mantle. Your core is composed of inner core and outer core. Now, it is being observed until now that inner core releases more heat, more pressure. This is the reason why most of the plates move. And again, one of the cause of earthquake is the plate tectonic or the movement of plates or the rocks. That is why it is directly connected to what? Earthquakes are directly connected or interrelated to what is our topic?
Tectonic plates.
What is our topic previously? To faulting. Okay?
Tectonic. Oh, yes. Well,
Faulting. Again, tectonic plate theory is part of faulting. It is movements of rocks also. Again, we are actually on big rocks moving until now. Okay? So if can you see the illustration? Can you see the illustration?
It's still loading on my screen, sir. It's still loading on my screen. Oh, yes, yes, I can see it now.
Okay. So this is a dissected part of Earth wherein you can see the component of Earth, like the core, the inner core, the outer core, mantle, and the crusts. While the edges of faults are stuck together, the rest of the block is moving. The energy that would normally cause the blocks to slide past one another is being stored up. When the force of the moving blocks finally overcomes the friction of the jagged edges of the fault and it unsticks, all the stored energy will be released. Remember that we are building up, or nature is building up pressure there. That is why. So if it unsticks, therefore, it will release its energy. The energy radiates outward from the fault in all directions in the form of seismic or seismic waves. Okay, there is it. The terminology is there. Please take down notes. Seismic waves, like ripples on a pond. So have you tried rippling the pond? Like for example, you will drop some stone in the pond and you can see the ripple effect.
Yes.
That is one way also. Now, another illustration on how seismic waves move. The seismic waves shake the earth as they move through it. And, and when the waves reach the earth's surface, they shake the ground and anything on it, like our houses or even us. Again, seismic waves ripples like a pond. Ripples like a pond. And these seismic waves is the reason why the earth shakes and why there are some damages in that area, like our houses or even us. We are affected. So let's move now. Let's focus on the seismic waves, right? Let's tackle on intensity and magnitude. What are or what is the differences or what are the differences of intensity when you say intensity and when you say magnitude? Okay. The size of an earthquake depends on the size of the fault. Correct. Because the bigger the fault, the bigger the earthquake is. Right? The bigger the movement, the bigger the earthquake. And the bigger the pressure, the bigger also the output or the earthquake or the seismic waves. And the amount of slip on the fault. But that's not something scientists can simply measure with a measuring tape. Yes, it cannot be, measured just with a um, normal instruments or measuring instruments. Since faults are many kilometers deep beneath the Earth's surface. So how they measure the earthquake, by the way? They use a seismogram or seismogram recordings. Seismograph. Okay? Seismogram is the instrument used. Seismograph is the output or the printed output of a seismogram made on the seismographs at the surface of the earth to determine how large the earthquake was. A short wiggly line that doesn't wiggle very much means a small earthquake. Have you seen a seismograph?
No, sir.
Okay. And a
Is
long
it
wiggly
the
line.
thing that looks like a camera?
And no, Rabi. A seismogram or seismograph, this looks like uh, an instrument that you will put in the ground, okay? And then it measures the intensity of the movement, okay? It also predicts, no, it cannot predict, but it can actually measure the amount of intensity. right? A long, wiggly line that wiggles a lot means a large earthquake. Again, it moves. It depends upon the magnitude and the intensity. The length of the wiggle depends on the size of the fault, and the size of the wiggle depends on the amount of slip. Again, the length of the wiggle, the length depends on the size of the fault, and the size of the wiggle depends on the amount of slip. The size of the earthquake, again, the size of the earthquake is called its magnitude. The size. Take note. Again, the size of the earthquake is called magnitude. There is no one magnitude for each earthquake. Scientists also talk about the intensity of shaking an earthquake. And this varies depending on where you are during the earthquake. Magnitude measures the energy released at the source of the earthquake. Again, magnitude measures the energy released at the source of the earthquake. Take note, magnitude is determined by the measurement on the seismographs. Okay? We're still in the magnitude. Intensity measures the strength of the shaking produced by the earthquake at a certain location. Again, magnitude is the size of the earthquake, and it measures the energy released at the surface of the earthquake. This is the one measured by the seismographs and seismograms. Intensity measures the strength of the shaking produced by the earthquake at a certain location, meaning to say that intensity is determined from the effects of the people, human structures, and natural environment. So these are the damages. Again, intensity can be determined with the effects on people, how the people are being affected, and what are the damages. Like in our previous earthquake, like in Bohol, we have a lot of parishes or a lot of churches being damaged, correct? Even Santo Niño, right? Have you heard the news before? The big earthquake, even Santo Niño was damaged.
Yes. The one in 2013?
Yes, even Santo Niño is damaged,
Yes.
correct? So those are the intensity. Again, magnitude and intensity are very different because magnitude can be measured to a seismogram or seismograph. And this is the size of the earthquake. Intensity measures the strength of the shaking produced. So we can measure the intensity by the effects on the people, the structures, and the natural environment. Question so far? Before we move, Rabi, yes?
Um, the magnitude, sir. The magnitude is measured during wait no during the earthquake.
Yes,
At the epicenter, while
yes,
the intensity is measured after the earthquake and not just at the epicenter.
yes, correct. Not just the epicenter, because the effects may be far, far behind or far away from the epicenter. Any other question? Sebes. Okay, again, class, I want you to be serious with our subject. Oh, if you're going to look at my wall, you can see my students there exchanging ideas on how our class are being going are being, done. Those are my previous students. So that's how serious I am with science, and it's a big insult in my side if you take for granted my subject, because science is my life, to tell you honestly. That's it. It's not just a subject for me. It is my life. And hopefully also, you'll appreciate the beauty of science and you will live in it. Remember that science is not just a lesson, it is happening in your surroundings, right, Rabbi? It is anywhere. And I want you to learn this by heart, not just to pass the subject. Passing the subject is supposed to be your, your second, priority. Your priority is supposed to be is to learn the lesson, to live with it. No? That is why I am really, uh, I'm wondering why you don't like the subject or others don't like the subject. It's really good to know science and you can explain the phenomena. You know what I mean, right? Just tell your classmates or other classmates to communicate to me with your project or with your performance task because only few pass the performance task. Shall we continue? Okay, seismograms come in handy for locating earthquakes too. And being able to see the P wave and the S wave is important. Again, another terminology, P wave or the primary wave and the S wave or the secondary wave. You learned how P waves and S waves each other shake the ground. It has a different behavior in the ground in different ways as they travel through it. P waves are also faster than S wave. And in fact, and this fact is what allows us to tell where an earthquake was. Again, P wave or the primary wave moves faster than S wave or the secondary waves. To understand how this works, let's compare P wave and S wave with the lightning and thunder. Okay? What comes first? Lightning or thunder?
Lightning.
Why? Why lightning?
Um, because it is light.
What, Ravi?
Light travels faster than sound, and when light travels faster than sound, so we see
Correct. Light travels faster than sound. That is why you can see first, or you can see first light and followed by, after how many seconds, followed by a thunder. Okay. So during the thunderstorm, you will see first the lightning and then you will hear the thunder. If you're close to the lightning, but by the way, they're actually moving uh simultaneously. Okay? So, but light travels faster than sound. So sound will be left behind. That is why you can hear the sound after a lightning. Correct? The thunder will boom right after the lightning. But if you're far away from the lightning, you can count several seconds before you hear the thunder. Yes, correct. The farther you are from the storm, the longer it will take between the lightning and the thunder to be observed. So this is now the illustration of a P wave and the S wave. So you can see first the primary waves and then the secondary waves. P waves are like lightning and S waves are like thunder. Again, there are some characteristics of these waves. The primary waves travels faster and shake the ground where you are first. Okay, it shakes the ground. That is why you can locate or you can actually observe where the actual earthquake is because of the primary waves. Then the secondary waves follow and shake the ground also. And if you are close to the earthquake, the P and S wave will come one after another. But if you are far away, you will be more will be more time between the two. It will take time for you to identify if you are far. Again, P waves travel faster and shake the ground where you are first. S wave follow the shake on the ground also after the primary wave. So these are the movements of the primary wave and S wave. So the primary wave is moving in opposite or same direction, or no, in opposite or away from each other, and the S wave shakes the ground, or the secondary wave shakes the ground. Question so far? Question so far? We still have 1 minute left.
Sir, are the P waves moving horizontally, and
Yes.
the S waves? Oh wait, move up. Oh wait, no. Do the P waves move sideways and the S waves